NEC Article 334.15b addresses the protection from physical damage and specifically covers exposed NM non-metallic sheaves cable, or Romex. This section details how Romex should be installed to prevent damage, and it implicitly prohibits its use inside conduit for general wiring purposes. The key reason for this prohibition lies in the design and intended use of Romex cable. Romex is designed for dry locations and relies on free air for heat dissipation. When Romex is installed in conduit, several issues arise. Firstly, conduit restricts airflow, preventing the cable from dissipating heat effectively. This can lead to overheating, which can damage the insulation and potentially cause a fire hazard. Secondly, Romex is not designed to be pulled through conduit. The outer jacket of Romex is not as robust as the jackets of cables specifically designed for conduit, such as THHN or XHHW. Pulling Romex through conduit can damage the outer jacket and the insulation of the individual conductors, compromising the cable's integrity. Thirdly, conduit systems are typically designed to be grounded, and the use of Romex within a metallic conduit can create unintended grounding paths or ground loops, which can interfere with the proper operation of electrical equipment and increase the risk of electrical shock. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to consult the latest edition of the NEC for the most current requirements. NEC Article 334 covers non-metallic sheet cable, types NM, NMC, and NMS. Section 334.15 specifically addresses the protection from physical damage. Subsection 334.15 covers general. In other words, where subject to physical damage, NM cable shall be protected by conduit, electrical metallic tubing, Schedule 80 polyvinyl chloride rigid non-metallic conduit, or other approved means. The number 1 is NM cable installed in a location subject to physical damage must be protected. Secondly, approved methods for protection include conduit, electrical metallic tubing, Schedule 80 polyvinyl chloride, PVC rigid non-metallic conduit, or other approved means. Subsection 334.15b covers exposed front-on wall or ceilings. NM cable installed exposed along the surface of framing members shall be protected against physical damage where less than 8 feet above the floor. The number 1 is NM cable run exposed along framing members must be protected if less than 8 feet above the floor. Secondly, protection can be provided by running boards, guard strips, or other approved means. The prohibition of Romex in conduit is not explicitly stated in the NEC with the words "do not install Romex in conduit." Instead, it is implied through the limitations placed on its use and the requirements for proper installation and heat dissipation. The NEC provides specific guidelines for the types of cables that are suitable for installation in conduit. These cables typically have a robust outer jacket and are designed to withstand the stresses of being pulled through conduit. They also have insulation that is rated for wet locations and can withstand the higher temperatures that may occur within a conduit. When selecting cables for installation in conduit, it is important to consider the following factors. Firstly, the type of environment, whether it is wet, dry, or corrosive. Secondly, the ampacity requirements of the circuit. Thirdly, the voltage rating of the cable. Fourthly, the temperature rating of the cable. Fifthly, the type of conduit being used. Sixthly, the fill capacity of the conduit. The fill capacity of a conduit refers to the maximum amount of cable that can be installed in the conduit without exceeding the NEC fill requirements. The NEC specifies fill limits to ensure adequate heat dissipation and to prevent damage to the cables. Exceeding the fill limits can lead to overheating and premature failure of the cables. There are specific types of wiring methods approved for use inside conduit, such as THHN, XHHW, and THWN. These conductors are individual wires with specific insulation types designed for conduit installations. THHN is a thermoplastic high heat resistant nylon coated wire, suitable for dry or damp locations. XHHW is a cross-linked polyethylene high heat resistant water resistant wire, suitable for wet or dry locations. THWN is a thermoplastic heat and water-resistant nylon-coated wire, suitable for wet or dry locations. These conductors are typically pulled through the conduit after the conduit has been installed. The NEC provides detailed tables and guidelines for determining the appropriate size and type of conduit for different wiring applications. These tables take into account factors such as the number and size of conductors, the type of insulation, and the ambient temperature. Using the correct size and type of conduit is essential for ensuring the safety and reliability of the electrical system. In summary, NEC Article 334.15b does not explicitly say do not put Romex in conduit, but it implies it through the limitations placed on Romex. Romex is not designed for use in conduit due to heat dissipation issues, potential for damage during installation, and grounding concerns. Always use appropriate wiring methods such as THHN or XHHW when installing conductors in conduit. Consulting the NEC and following its guidelines is crucial for ensuring electrical safety and compliance with local regulations. Always consult with a qualified electrician for any electrical work to ensure that it is done safely and in accordance with the NEC and local codes. The NEC provides specific guidelines for directing conductors based on the number of current carrying conductors in a conduit. When multiple conductors are installed in the same conduit, the heat generated by each conductor can raise the overall temperature within the conduit. To prevent overheating, the NEC requires that the ampacity of the conductors be reduced or derated based on the number of conductors. The derating factors are specified in NEC Table 310.15 current. It is important to note that the derating factors apply only to current carrying conductors. Grounding conductors and neutral conductors that do not carry current are not counted when determining the number of current carrying conductors. The NEC also provides guidelines for calculating the voltage drop in electrical circuits. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to the conductor's resistance. Excessive voltage drop can cause equipment to malfunction and can also reduce the efficiency of the electrical system. The NEC recommends that the voltage drop in branch circuits should not exceed 3% and the voltage drop in feeders should not exceed 5%. To minimize voltage drop, it is important to use conductors that are large enough for the load and to keep the length of the circuit as short as possible. The NEC also provides guidelines for grounding electrical systems. Grounding is the process of connecting electrical equipment and wiring to the earth. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect people from electrical shock and to prevent damage to equipment. The NEC requires that all electrical systems be grounded, and it specifies the methods that must be used to ground different types of equipment. Grounding electrodes, such as ground rods and ground plates, must be installed in accordance with the NEC. The size and type of grounding electrode required depends on the size and type of electrical system. The NEC also provides guidelines for overcurrent protection. Overcurrent protection is the use of fuses and circuit breakers to protect electrical circuits from excessive current. Overcurrent can be caused by short circuits, ground faults, and overloads. Fuses and circuit breakers are designed to interrupt the flow of current when an overcurrent condition occurs, which helps to prevent fires and to protect equipment from damage. The NEC specifies the size and type of overcurrent protection that must be used for different types of circuits. The size of the overcurrent protection must be matched to the ampacity of the conductors being protected. The NEC also provides guidelines for wiring methods. Wiring methods refer to the ways in which electrical conductors are installed and protected. The NEC recognizes a variety of wiring methods, including conduit, cable, and raceway. Each wiring method has its own advantages and disadvantages, and the NEC specifies the conditions under which each wiring method can be used. When selecting a wiring method, it is important to consider factors such as the environment, the type of building, and the aesthetic requirements. The NEC also provides guidelines for electrical safety. Electrical safety is the practice of working with electricity in a way that minimizes the risk of electrical shock, fire, and other hazards. The NEC includes many requirements that are designed to promote electrical safety, such as the use of ground fault circuit interrupters, or GFCIs, in wet locations and the use of arc fault circuit interrupters, or RSIs, in bedrooms. It is important to follow all electrical safety guidelines when working with electricity. Always disconnect power before working on electrical equipment, and use appropriate personal protective equipment, or PPE, such as rubber gloves and safety glasses. The NEC is a complex and comprehensive document, and it is important to consult the latest edition of the NEC for the most current requirements. The NEC is available for purchase from the National Fire Protection Association, or NFPA. It is also available for free online. It is important to note that the NEC is not a law. However, many states and local jurisdictions have adopted the NEC as part of their building codes. In these jurisdictions, compliance with the NEC is required by law. Always check with your local building department to determine the electrical codes that are in effect in your area. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These standards and regulations may be issued by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. It is important to be aware of all of the applicable standards and regulations when designing and installing electrical systems. The NEC is constantly evolving to reflect changes in technology and best practices. The NEC is updated every 3 years, and it is important to stay up to date with the latest changes. The NEC includes many new requirements and revisions that are designed to improve electrical safety and to make electrical installations more efficient. Always consult the latest edition of the NEC for the most current requirements. In conclusion, NEC Article 334.15b addresses the protection from physical damage for Romex. While it does not explicitly prohibit Romex in Conduit, the limitations placed on its use make it unsuitable for such applications. Proper wiring methods and adherence to the NEC are essential for ensuring electrical safety and compliance.